And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So without wasting any time, let's get started. Today's problem is LRU cache, which is marked as a hard level problem. Let's find out what we will be given into this problem and what we have to do. So basically we are given one class LRU cache, okay, in which first point is this a constructor of the class LRU cache constructor, and in this constructor one parameter is passed, which is the cap of integer type, basically means capacity. Okay, and then there are two more functions. First one is the get functions with one parameter as the key, and next one is the put function with the parameter as key and value. Okay, all right, now let's see what we have to do and what are these functions simplifying. Okay, so first thing is first, what is cache and what is LRU? So here in this question it is not given. So first of all, let me tell you what is cache. Cache is basically a memory in our mobiles, in our laptops, desktop, everywhere. And this memory is very fast. Okay, very fast memory this is. But the issue is that it is very costly and the size of this cache memory is very small. Okay, very small, very few things can be stored in the cache, but it's very fast. Okay, all right. And what is this LRU means? LRU basically means least recently used cache. Okay, so what we have to do, so basically look, in the cache we have to store some data, and what happens is ki yaar, if that data is, first of all, if we have to look, cached is a memory, okay, in which some data is stored. And now let's suppose I have to search some data. So first of all, I will check in my cache if it is present or not, because cache is very fast. Okay, so if it is present in cache, we will simply return it from the cache. But if that specific photo, specific anything which we are searching, if it is not present in cache, we will search it in our main memory. Okay, so this is how the flow works. And LRU cache basically means ki least recently used. So look, cache, in cache we cannot have all the data, our data, because it's very small and costly. So there is a algorithm LRU cache, which means ki now let's suppose we will remove those data from our cache which are not recently used, and we will store more those data which are recently used, because like basically means ki if I have used it recently, it means we can use it again and again. But if something is, some contact is there, some any data is there which is not used in recent times, we will remove it from our cache. Okay, so this is one algorithm. There's one more algorithm, LFU, least frequently used, like the based on the frequency we will remove the element from cache. But let's skip it for now and let's see what is LRU cache. Okay, I think a little bit thing will be clear ki what, how cache, what is cache, how, what is LRU and all those things. Now let's see what we have to do in our problem. Okay, so look, we are given one capacity cap, which means ki we can store these many data into our cache. Okay, all right. So int capacity is anything which we are given, and we can store those many data. Okay, all right. Then there are two functions, get and put. Basically means, let's suppose I have stored. Okay, so first of all, let's suppose put function. What is put function? Put function will give me two things, key and value, and we have to store it in our cache. Okay, so let's suppose if I got put 1 comma 2, basically means I will store 1 as a key and 2 as a value. Okay, all right. And then there is a get function which will use to get me the value of the key. So if I will use get 1, basically means get the value of 1. This is one key, and what is its value? 2, and so I have to simply return 2 here. Okay, so two functions is there. One is used to add data into our cache, and second one is to get the response, get the answer of our data, of our query. Okay, so getter setter functions, very simple, is there. So this is what it is. And cap is there, capacity key basically means if capacity is equal to 4, we can only store 4 key value pairs. And if let's suppose fifth key value pair come, so what we will do, we will remove the least recently used data. we will remove the least recently used data from our cache. Okay, so in this way we have to do. And if let's suppose I have added 1 with value 2, and then I want to get 3, the value of 3. So 3 is not present. 3 is not present in our cache. So what I will do, get the value of key of x if present, else return -1. So we will simply return -1. I think the problem statement will be a bit clear to you now. Now let's quickly move to one note where I have written a good test cases, and then we will understand this problem in detail. Okay, all right, let's go. So here let me quickly use a draw functionality. Okay, all right, so let's suppose this is our cache. Okay, it has capacity 3. It has capacity 3, so it can store 3 key value pairs. I think I've made it small. Let me make it a bit big, something like this. 3 elements are stored. Okay, so first one I got put 1 comma 3. So I will simply add one key with value as 3 into our cache. Okay, this is our cache. Okay, after that I got put 2 as well, 2 key, and value, its value is also 3. Okay, no issue, I have put it very simply. Then I got put 4 comma 1. Okay, no issues, 4 is added and its value is 1. Okay, all right. Then I am asked, return me the value of 1. So I will check in cache if 1 is present. Yes, 1 is present, its value is 3. So I will simply return 3. Okay, no issue till that. Then I am asked get 3. Okay, so 3, is 3 key present in our cache? No, 3 key is not present. So basically what I will return, if you remember, I told I will return -1. Okay, like this is, this 3 key data is not present. Okay, then I am asked to put 3 with key as 4. Okay, so now look, um yeah, okay, so now look, put 3 comma 4, but our capacity of this cache is full now. Our cache capacity is full, we cannot add more, so we have to remove some data. Okay, all right, now look, 4 is added in the very last. Okay, and after that I have used 1 as well. I have used 1 as well. So which is the least recently used, data? That is this. This is the least recently used data, because look, 4 is added at the last. So, and after that I have fetched 1, I have used 1. So which is the least recently used data? 2. So I will remove it. Okay, so let's quickly remove it and put 3 with 4. So now I will replace it with 3, and 4 is added. Okay, all right, now if I ask you at this point which is the least recently used data, what you will answer me quickly? Look, 3 comma 4 is the latest add. Okay, so its rating is, let's suppose, first. Basically if I start from decreasing, so it is the um, currently most recently used. Okay, all right, after that I have asked get 3. Okay, so remove it, get 1. Okay, so this is the second most frequently used data, most frequent. Okay, after that 4, so this is the third. So if at any point now I have to add any data, it will be replacing 4. It will be replacing 4. Okay, all right, now I'm asked to put 2 comma 3. I'm asked to put 2 comma 3. So where I will put, I will simply put it here in the place of 4 1. So now 2 is added with 3. Okay, then I am asked to return get 3. Okay, get 3 is basically 4. Then I am asked to return get 2. Get 2 is basically 3. Then I am asked to get 4. Get 4 is not present, so I will simply return -1. This is what it is, and I think now the problem statement will be very, very clear to you. And now we will move on to the approach which we are going to take, which is basically very, very simple. Okay, all right. Now let's see this another test case with the help of approach which we are going to take. Okay, all right. Capacity is again 3. So my cache I will make, and I will basically use, I think it will be clear which data structure we are going to use. We are simply going to use a map data structure. Okay, and we are also going to use linked hash map, not simple hash map, but linked hash map. Why? Because look, yeah, in linked hash map, what happens is key linked hash map maintains the order of key value pairs, but in simple hash map it does not maintain. What does this mean? This means suppose I have added 1 3 into my map. Okay, after that if I will add 2 3, and then I will, let's suppose, add 4 to 5. So 4 to 5 can added at any position. 4 comma 5 can be added here as well. 4 comma 5 can be added here as well, and it can be added here as well. So basically in only hash map we do not maintain the order of insertion. So basically look, if I want to add 4 5, so it can be added here as well. Okay, and then when we will iterate over the keys of this hash map, I will get 4 at first place, which is not correct. We have added it at the last, so I want to get it at the last only. Okay, so this is the issue with the hash map, and that's why we are going to use linked hash map, which basically maintains the order of insertion. Okay, all right, I think it will be clear. So we will simply make a integer type of linked hash map, and capacity is of 3. Okay, all right. Now when I get 1 comma 3, I will simply add it into our map, because my capacity is only 1 till now, like map size is only 1. After that I get 2 comma 3, I will simply add 2 comma 3. After that I get 4 comma 1, no issue, I will simply add it 4 comma 1. After that I am asked to return value of 3. So 3 value key is not present here, I will simply return -1. Okay, now I am asked to insert 3 at 4. Okay, all right. So you can see which is the least recently used element here. It is 1 because it was added at the very beginning, and after that it is not used at all. Okay, so what I will do, I will simply remove this 1 comma 3 from our cache, because cache is very small, capacity is only 3, and now I will simply add 3 with value 4. 3 is added with value 4. Okay, no issue till this point. After that I am asked, this is also done. After that I am asked to put 2 comma 5. So what I will do, basically 2 is already added with 3, but now I have to add, change its value. So look, if I will keep it here only, so it means it is the least recently used. This is the order. We are now maintaining the order with linked hash map. So I have to update the value, so it will be removed from here and then it will be kept here, 2 comma 5, which basically means at any point, at this point 4 is the least recently used and it will be deleted. Okay, at any point. Okay, all right. Now what I have to do, this is also done. Now the value, this is the new operation 5 to 1. Okay, so where it will be added, the first, this is the least recently used element. At this point it will be removed and 5 will be added here in the last. So if at this point I have to ask what is the least recently used, least recently used is this 3. Okay, all right. After that I have to get 3. Okay, so when I have to get any element, this 3. Okay, so now 3 is again used, like most recently used. So I will remove it from the very starting of the hash map, and I will simply put it here with the value. So now again in this order, which is the least recently used, this 2 is the least recently used. So in this way we are maintaining the order, and whenever we are, let's suppose, reading the value from our hash map, we have to again insert it at the very last, so that, I think you guys are getting. Okay, after that get 2, so get 2 is value 5, get 4 is not here, return -1, and that is it. So basically I think the approach which we are going to use is also will be very clear. Now let's move on to the code section and write the code of it. When I will write the code, it will become crystal clear to you. Okay, all right. All right, let's quickly write the code. So first of all, if you remember what all steps I will be using. So first of all, I have to use a hash map, not hash map, linked hash map. So basically linked hash map is the class, and we can simply first of all declare this map of integer type, something like this, and let's name it as cache, or anything you can use cache, we will use cache. Okay, and another thing is, let's suppose int capacity. Okay, so we are only declaring it. We are only declaring it at this point, and we will be using it here. We will be using it here. Okay, so you can see these functions are static as well. So either remove static from this point, or we have to make our these variables as well static, because non-static variables cannot be used in static functions. Okay, I think this will be very, very clear. So in this LRU cache, which is basically the constructor, we will initialize our variables map, cache, and capacity. Okay, so cache is basically new linked hash map, something like this. Okay, and capacity I will initialize it with uh, cap. Okay, all right. So what does this mean? Basically, you will tell why I'm initially declaring it globally, because if I will declare it in this constructor, we cannot use it in these functions. So we are declaring it inside the we are declaring it as a global, and we are initializing it in the constructor. Okay, because constructor is called at the first. If you want to read the source code, you can read it here. You can see, first of all, this LRU cache is basically our class which we are implementing, and we are first of all taking a or making an object of it with cache, and we are passing the capacity. So this capacity will be passed here, and we will initialize it. Okay, so always read this as well. Okay, now let's move on to the code section. We will first of all complete get and set. Anything you can complete now, as I have already explained it, I think, quite better. Okay, so get. Okay, so basically, look, if cache, I think I'm writing cache is spelling again and again wrong. So if not cache dot contains key, so if it does not contain, what I will do, I will simply return -1. Okay, all right. Otherwise, I will get the value of it. Get value cache dot get key. Okay, but look, before returning it, now this element, this key is most recently used, so I have to update its position from the map as well. How I'm going to update? Simple, cache dot remove key. Okay, it's removed from its earlier position, and now it will be added at the very last. So cache dot put key, and its value is this val, which I have already stored in this variable, and after that, now it is marked as most recently used, and I will simply return it as val. Okay, very, very simple. And now our this get function is completed. I have to just complete our put function as well. So what I will do, look, if cache dot contains key of this key, so it means in this case we don't have to remove, we don't have to delete any data, we don't have to delete any data because it's already present. But we don't have to remove any data, but we have to make this key as most recently used, because now we are updating it. So let's suppose it was least recently used, but we are now updating this key, so it will become most recently used. Basically means add it again, remove it from its position, and add it again to the hash map. Okay, so we have already done it. Let's quickly do this. Let's quickly copy this line. Key, we will remove it from cache at its earlier position, and then we will again cache, CACHE. I think I'm writing it's spelling it correct. Okay, so cache dot put key and its new value. Very, very simple. Okay, but look, if this key is not present in the hash map, and now in this case we will simply return. Okay, all right, very, very simple. In this case we will simply return. But now if our cache dot size is equal to capacity, so what I will do, I have to remove any element from the map. So which element we will remove? Let's quickly make it as rem is equal to -1 at this point. Now what I will do, I will simply iterate over this map once. So for int I of cache dot key set. If you are using C++, I will add that code as well in our GitHub, so you can get it from there. The logic is basically same. Okay, so first element I will get from our cache map, and we will initialize our rem is equal to I. Basically means the first element. And now what I will do, I will simply do break, because I need to get the first element from our cache. And after that what I will do, I will simply write cache dot remove rem. Okay, and after removing the least recently used element from our cache, what I will do, I will simply put the most let's suppose the key value pair which I have to add. So key comma value, and I think it should get accepted now. Let's quickly try to compile this. And meanwhile guys, if I have explained this with you fully, so please subscribe the channel and like the video, because it will really motivate me, and I'm making this video in midnight. Okay, so subscribe the channel, share it with your friends, and yeah, I think it will get accepted. Let's quickly see. I hope it will not give me TLE. uh, Come on, come on. Okay, yeah, it's getting accepted. So that's it for today. I'm going to see you again tomorrow. Till then, subscribe the channel, like the video, and bye.